Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. And John, today we're talking about finding the surface area of a cylinder. So I just want to take a minute to talk about what surface area is, because when I was growing up, I feel like sometimes it confused me. I was like, what exactly am I trying to figure out here? So basically, it's how much area something would cover if you cut it up and like spread it out in two dimensions. So for a cylinder, I have a nice little prop here. My husband got me a can of Pringles, which is a cylinder because it's two circles with a kind of a rectangle curved around it. The surface area would be how much. It's almost like if you were painting something, how much paint would it take to cover, the top and the bottom and the side? So surface area is two-dimensional. And when I was growing up, the way I was taught to find the surface area of a cylinder was to memorize this formula and then plug and chug. And I wasn't good at memorizing, but this formula wasn't too tough because I just remembered that it was two terms, which was my memory trick to remember there was a 2 involved in both of them. They both had pi, they both had r, and then I just had to remember, okay, one's going to have h and one's going to have, r squared instead of plain r, which again kind of reinforced that it was two-dimensional. I had to multiply inches by inches. So the way I plugged and chugged is I'd say, okay, I need to find the area. So it's 2 pi, and then the r is given, the radius is 3, and that's in inches. The height is 10. Then it's going to be 2 pi, and the radius is 3, and this one's going to be squared. And I'm just going to go through and simplify, and I'm going to leave pi in the answer. So 2 times 3 times 10 is going to give me 60. So that's 60 pi. 3 squared is 9. 9 times 2 is 18. So that's going to give me 18 pi. So I'm just going to add those up, and that's going to give me 78 pi. And I always want to remember my units of measure. So it's 78 pi, and that's going to be in inches squared. So John, take it away. What's the current thinking about the best way to find the surface area of a cylinder?
I agree with you. When I learned how to do this myself, I also learned it this way by finding the radius and the height and plugging it in. But the issue is when students start learning a lot of different types of solids, they often confuse which one had an R, which one had an H, which one was squared, which one had the 2, things like that. So a more intuitive conceptual approach to surface area involves students breaking down the three-dimensional solid into the shapes that actually make it up. So, for example, with the cylinder, as you had mentioned, if you think of it as like painting, we would be painting both the top and the bottom of the cylinder, and that would be basically painting two circles. The top is a circle and the bottom is a circle. We know that the area of a circle is pi r squared. So I have pi r squared on the top, and I have the exact same pi r squared because the top and the bottom had to be the same on the bottom. So that's where the 2 pi r squared comes from. And if I wanted to, at this point, I can plug in 3, for my r to find just the area of the top, which would be 9 pi. And then same thing on the bottom because it's supposed to be the exact same dimensions. Pi times 3 squared is 9 pi. So that's for the top and the bottom. Then for the side, you had mentioned a rectangle curved around. That's exactly what we want to explain to our students, that when we paint around a cylinder, it's really a rectangle that we fold and have it take the shape of those two circles. The width of the rectangle is h, this part right here. That's the same thing as the height of the cylinder. And the length of the rectangle, that's the interesting part. That has to fit all the way around the circle. And the distance around a circle is the circumference. Circumference is something students learn in their middle school math classes. Circumference is 2 pi r. It gives us the total distance, or perimeter, if you will, around a circle. So if I want to find the area of a rectangle with sides h and 2 pi r, I just multiply those together to get 2 pi r times h. So if I wanted to find that area, I'm just doing 2 pi times 3 the radius times 10 the height. And that gives me a total area there of 60 pi. So then taken all together, if I want to calculate the total surface area, I add the area of the top plus the area of the side, which was 60 pi, and the area of the bottom, which was another 9 pi, which will give me a total of 78 pi inches squared, because we are dealing with area. This would be what we call an exact area. A lot of times we do want the exact answer, or some books will say in terms of pi, because we want to preserve the accuracy. But if the question says to give an approximate area, or something more rounded, it works out to about 245.04 if I do it on the calculator. But they're both more or less the same answer. The pi answer is just more exact and doesn't involve rounding.
Okay, great. And the nice thing about this approach is that it reinforces other parts of geometry that students have already learned. Like, it reinforces the area of a circle is pi r squared. It reinforces the circumference of a circle. When I was learning this, I remember someone trying to tell me how the curved part was a rectangle, and I was like, doesn't look like a rectangle to me. But a nice way to think of it is who hasn't rolled up a piece of paper, right? And that forms a cylinder. So that's kind of an intuitive way to grasp it.
Right,
So,
or you can rip the label off your Pringles container, and if you ripped it off, it would flatten out to be a rectangle.
Yes. And the best part about that is then you get to eat some Pringles.
Yes, once you pop, the fun don't stop.
All right, speaking of fun, I'm ready to try a problem. Okay, so now I'm going to find the surface area of this cylinder with the radius of 5 centimeters and a height of 9 centimeters. So what we did was we broke it out to the 3 faces: the top circle, the edge here is this rectangle, and then the bottom circle is shown here. So one thing I want to mention is sometimes they might give you the diameter instead of the radius, in which case you can just cut the diameter in half. So if they had said the diameter was 10 centimeters, it would have been the exact same problem. So I'm going to go ahead and dive in. First, I'm going to calculate the area of this top circle. So the formula for that is area for a circle is pi r squared. And I've got my radius as 5 centimeters. So I'm going to put a 5 in there. And 5 squared is 25. So my area is 25 pi squared. I'm sorry, 25 pi, and that's centimeters squared. Then for my rectangle, let me change pen colors here. So this height here we know as 9 centimeters. That's our H. Then, as John taught us earlier, this edge here, it has to fit all the way around this circle. So it's the circumference of that circle, which is 2 pi r. So to find the area of the rectangle, I'm going to go over here. The area of the rectangle is going to be 2 pi rh. And we know that the radius is 5 and the height is 9. So 9 times 5 is 45. 45 times 2 gives us 90. So the area of the rectangle is 90 pi. And that's also centimeters squared. Then just one face left. But the good news is we already did it, because the third face is the bottom circle, which is identical to the top circle. So we can just say we already know that area. It's going to be 25 pi centimeters squared. So now to kind of add it all up, literally, let me change pen colors. So I'm going to say, okay, the surface area of the cylinder is the top circle, which is 25 pi, plus the rectangle, which is 90 pi, and finally the bottom circle, which is 25 pi. So adding those up is going to give me 25 plus 25 is 50. Add 90 to that, it's going to be 140 pi, We always want to remember our units of measure. In this case is centimeters squared. John, I really like that. It really breaks it apart and it lets you put it all together, understanding each piece.
Right, and I feel like it's a better alternative than the all or nothing approach with the formula. If you remember one part of it, it's basically all wrong. If you forget a 2 or a square, then the whole thing is wrong. Whereas if you have a mechanism to fall back on and a way to break it down into smaller pieces or problems, that can give you the area in a more intuitive way.
Wonderful. Great. All right. Well, thank you so much. Thank you, everyone, for watching. We're Math Videos for Parents. You can follow us on Facebook or on YouTube. And if you have any problem requests, please reach out to us. We really want to help you help your kids with math.
Hope you enjoyed the video and look forward to seeing you soon.